Value for x here. What is x? Yeah, you think, okay, instead of x, it's just some number plus 2 is equal to 3. So that number has to be 1. There's no other answer for that other than 1. Okay. Let's look at another one. Let's look at this. What about this one? Y take away 1 is 5. Yeah, so you're on the same scale. Something take away 1 is 5. The only number that works for that is 6, so we can say y is 6. Now, I want to be able to get to a stage where I can solve something like this. I want to be able to solve something like that. Now, the problem... Yeah, this equals. So there's some number, some value for x that makes this all equal. Bit like there's some value for x that makes this equal. So you think about, okay, this side has got to equal that side. And for that to happen, 1 plus 2 is 3, and that equals 3. So that equals that side. There's a number that works for x here. Now, it might be a nice whole number. It might be a fraction. It might be a negative fraction. But it makes this side equal to that side. It makes it equal. Finding that value can be very difficult. So we have to build up to a position where we can solve that. And I guarantee you by the end of this unit, you'll all be able to at least attempt to solve this with a method, which means we need to know a method. The method has got to work for the easiest ones and the hardest ones. So let's get to figuring out what method we're going to use. I'm going to use a method that has 2 steps to it. Do the opposite to both sides. That's it. Do the opposite to both sides. That doesn't make much sense now, but it will make sense hopefully in a second. We want x equals at the end here. We don't want this pesky plus 2. To get rid of that, I'm going to do the opposite operation. The opposite operation to adding 2 is what? Subtracting 2. So if I subtract 2 and write it underneath here, I have, I've got rid of adding 2 and subtracting 2 is nothing. But I've done I need to do it to both sides. Both sides of what? Both sides of the equation. There's a left side here of the equation, and there's a right side. What's the balance point of the equation? The equal sign is where we balance the equation. That's what we pick sides of the equation. So I've subtracted 2 from one side of the equation. I need to subtract 2 from the other side. Do it to both sides of the equation. Otherwise, I've changed it. It's a bit like simplifying a fraction. If I have a half and I multiply this by 2, but I don't multiply the bottom by 2, I've changed the fraction. But if I do multiply the bottom by 2, I get an equivalent fraction. So I create an equivalent algebra statement. Now I haven't got there yet. Plus 2 minus 2 is nothing. They cancel each other out. That's great. Nothing. But I still have this x here. The equal sign still sits here in the balance point, and 3 take away 2 is 1. Now, what most people say is, that seems like a lot of work for an answer we already knew. And it is a lot of work for an answer we already knew. But I'm introducing a method that will work for the difficult one I had down here. Let's think about this one. This is a subtraction of 1. What's the opposite to subtracting 1? Adding 1. What do I do? Well, I add 1 underneath to both sides. That's to the left-hand side and the right-hand side. I draw a line underneath. What happens? Something will always cancel. Something disappears with this method. I'm left with just y here. There's nothing else on this side of the equals. 5 plus 1 is 6, and now I have my answer. Let's do some more examples. What happens if it's not just adding and subtraction? What about 3x's are 12? I kind of know the answers to this, but what about my method? Do the opposite. This is multiplying by 3. Isn't it? If the letters are shoved together, they are multiplied. What's the opposite to multiplying by 3? Dividing by. divide by the same number. So we're using the same numbers that are here. For here, I use 2. For here, I use 1. Here, I'm using 3. If I divide both sides by 3, well, what happens on the right-hand side, it's pretty easy, is 4. What happens on the left-hand side? 1? No. Well, 3 divided by 3 is 1, isn't it? Yeah. So 1x. Well, how do I write 1x? X. So they have effectively just cancelled each other out. Think of any number. Multiply it by a number. And then divide it by that same number. What's the answer here? 4 times 3 is 12. Divided by 3 again is 4. So you might as well not have done all this and just kept this number. That's what I'm doing here. Let's do one final example. Uh-oh. Fractions or division. F divided by 4 is 7. How do I find out what F is? I do the opposite to both sides. What's the opposite to dividing by 4? Timesing by 4. Both sides. Write it something like this. You can write it in brackets if you wish, but times both sides by 4. The right-hand side, pretty simple here. 7 times 4 is just 28. What's happening on the left? It can become 4f and then divide by 4 if I want.
Yeah, so, or just f.
Or just f. Same thing happens here. If I multiply and divide by the same number, I'm left with just whatever I started with, which is just f. So now I have my answer. So I do the opposite. So if it's adding, I subtract from both sides. If it's subtraction, I add to both sides.